Consider the numbers 0, 1, 2, 3, 4, and 5. If each digit can only be used once, determine the amount of 4-digit numbers without restrictions. So for a 4-digit number, we can use 4 boxes in a row to represent the 4 positions that we're arranging. So if we have no restrictions, we need to work out how many numbers can take up each position. So in total there are 6 numbers, but for the first one, we cannot have 0. Because it's a number and not a passcode or something else, we cannot have 0 in that position. Therefore, in total, there are 5 numbers that can go there. For the next position, we've used up one of the numbers. However, 0 can be used here, so there's still 5 numbers remaining to go into this position. After that, we've used 2 numbers, which means there's 4 numbers left that can go here, and then 3 numbers that can go in the final spot. So if we do that, we have 5 times 5 times 4 times 3, which equals 300 different 4-digit numbers that we can create. For part B, we want to find the amount of 4-digit even numbers that can be made from 0, 1, 2, 3, 4, and 5. So again, we've got a 4-digit number, so we can represent that as a box. And the first thing we can do is we can say if it's an even number, let's consider the case where the last number is 0. So if the last number is 0, there is one option for that. And now when we go to the first number, because 0 is used up, there's still 1, 2, 3, 4, 5 numbers. Then we've used 2 numbers, so there's 4 left, and then 3 left for that position. So when we do 5 times 4 times 3 times 1, we get that there are 60 numbers if the last one is 0. However, there's another case that we can consider. So here again, we have our 4-digit number, and now we consider where the last number is 2 or 4. So because it would be 2 or 4, there are 2 numbers that can go in that position. And now if we think about the first number, we can't have 0 and either 2 or 4 is missing. So that means that there's 4 numbers left that can be in the first position. And then we've used up 2 numbers at this point. So we find that there are 4 numbers for the second position and 3 numbers left for that third position. So 4 times 4 times 3 times 2 is going to equal 96 numbers that are even if the last one is 2 or 4. So combining those 2 cases, we'll find the total number of 4-digit even numbers. So here we have 60 plus 96, which equals 156 different 4-digit even numbers that can be made from 0, 1, 2, 3, 4, and 5. For part C, we want to determine the amount of 4-digit even numbers less than 4,000. So this question steps up in complexity yet again, and we need to consider several different cases. So we still have 4 digits, so we can represent that as 4 boxes in a row. And the first case we're going to consider is if the final number is 0, because that will ensure the number is even. And if the final number is 0, there is one option that can go in that 4th position. So now we need to consider all the other positions in the number. So the first position, we know that 0 can't be there, and that because we need the number to be less than 4,000, we need that number to be 1, 2, or 3. So there's 3 options that can go in the first position, and then 0 and another number between 1 and 3 are used up. So we have 4 numbers left for the second position, and 3 numbers left for the third position. So we have 3 times 4 times 3 times 1, which means that there are 36 possible numbers which are less than 4,000 and ending in a 0 to make it even. So that's one of the cases we can have. Another case we can have for our 4-digit number is if the last number is 2. So if the last number is 2, there's one option to go there. And now we need to consider our first number. So we can't have 0 because it's a number. We can have 1. We can't have 2 because that's in the last position. We can have 3. But after that, the number will become bigger than 4,000. So there's only 2 numbers, either a 1 or a 3, that can go in the first position. Now there's 2 numbers that are used, so that means there's 4 numbers for the second position and 3 numbers for the third position. So 2 times 4 times 3 times 1 is equal to 24 different numbers that are even and less than 4,000 if they end in a 2. The last case we need to consider is the even 4-digit number if it ends in a 4. So if that last number is a 4, there's one number that can go in that position, and now we need to consider what the first number could be. So it can't be a 0, but it can be a 1, 2, or a 3. So there are 3 numbers that can go there, and then one number is missing, that is 1, 2, or 3, and the 4 is missing because that's in the last position. So that leaves 4 numbers for the second position, and 3 numbers then for the third position. So 3 times 4 times 3 times 1 is equal to 36 different numbers ending in a 4. So if we combine those 3 cases, we have 36 plus 24 plus 36, which is equal to 96 different numbers that are 4 digits and even that are less than 4,000.